Steps we've already done are inserting the sample, naming the experiment, and selecting the correct solvent. Now the next two steps is that we're going to lock and shim the instrument. From the sample info tab, you're going to click on the lock tab, deactivate the lock on the left side, and then activate the lock scan at the top. The wavy signal that's going to show up when you hit the lock scan is the deuterium signal, and we want to maximize that, so we're going to go to the Z0 tab, and that is what the last experiment was locked at. You can adjust by 1, 10, or 100, right and left hand click to increase and decrease respectively. After you optimize the lock signal, you are going to lock it and deactivate the lock scan and move to the shim tab. In the shim tab, you're not going to touch anything on the left, the Z0 lock power and lock gain, because those are already optimized when you did the lock signal. What you're going to adjust though is the Z1, Z2, and Z1C signals. You can adjust them also by the increments of 1, 10, or 100. And what you're going for here is to optimize the signal strength. You're going to look for the field to increase, and you want a signal strength between 60 and 70 range. In case of a surge, you don't want to fry the machine, but you don't want it to be too low that you're not going to get a signal. After you shim, you're going to check the range of your spectra you're acquiring. For this one, we're keeping it between -2 and 14 ppm. We're going to keep the spectrum wide just in case we don't know what we are getting. You can narrow it down if you know exactly what's in your sample. Once you check the spectrum width, you're going to click go, and this will run the experiment for you, and you're going to watch for any errors in the top part of the program, and if there's any errors, you can click the stop button so you don't damage the instrument. There are a few things that can happen if you don't lock or shim the instrument properly. One thing is that you just won't get a spectra. There will be an error and you have to restart the experiment. The second, the spectra will have a lot of noise if it's not set at the right levels, and that'll be hard to read. You might not get the right integration, and it'll be hard to know what you really have. The third is you will get a spectra, but the chemical shifts can be skewed if you didn't lock it correctly or you didn't lock it with the correct deuterated solvent. And lastly is you can damage the machine. You definitely want to lock and shim properly so you don't break anything within the instrument. It is very fragile. You'll know if the instrument is not locked or shimmed properly when you get your spectra back, or if there's any errors that occur when you're running the experiment. And how do you fix that is you'll have to restart with the locking and shimming process. This is an easier thing to do when you're running a proton and it's only a 20-second experiment, but if you're running it overnight, you really want to make sure you have the correct lock and shim before you run it. And you can do that by running a proton first and making sure you're getting a good spectral read before running an overnight. Some things to keep in mind when locking and shimming the instrument. The first thing is you're going to lock using the deuterated solvent in your sample, and this is important, especially when you run multiple samples with the same deuterated solvent. You need to keep things consistent across all three or multiple samples to be able to compare them. Second is you're going to shim using the Z1, Z2, and Z1C tabs. Third is don't move the Z0 lock power lock gain when you're shimming unless you need to increase or decrease the signal strength. Fourth, you're going to make sure that your signal strength when you're shimming is between the 60 and 70 range. You don't want it any higher in case the instrument surges. You don't want to break anything, and you don't want it any lower so you can get a good read on your sample still. The last thing is you're going to check the range of the spectra before you run it. It's good to keep it wide when you don't know what's in your sample, and then you could always edit the spectra after. A shim is a device used to adjust the homogeneity of a magnetic field, and shimming is the process that's carried out that we do to correct any inhomogeneities of the magnetic field during an NMR experiment. When we lock the signal, we lock it on a signal from the deuterium NMR solvent that we've used, assuring that multiple acquisition scans are synchronized and the NMR computer programs multiple pulses and collects the data from them accordingly. There's many ways that an NMR spectra can look if you improperly lock or shim. Here are two examples. One is if you get a lot of black fuzzy lines at the bottom, you haven't maximized the shims. If you lock your solvent your deuterium solvent for the wrong one, your chemical shifts will be off. They could be higher or lower than they're supposed to be. You could also get spectral lines that are below the x-axis, above the x-axis, and inaccurate readings.